Welcome to Build Up, the European Commission's portal for energy efficiency and renewable energy in buildings. Directly stemming from the Energy Performance of Buildings Directive, Build Up is the meeting place for everyone involved in making the European building and construction sector more energy efficient. Every month we focus on a topic that is key to making Europe's buildings as energy efficient as possible. Exploring that, you can find the latest content such as expert talks, webinars, case studies and more. From architects and engineers to academics and policy makers, we've got you covered. Build Up brings together thousands of registered members to reap the benefit of Europe's collective intelligence on all aspects of energy efficiency and renewable energy in buildings. The Build Up portal benefits from the expertise of our ambassadors. Drawn from industry and academia, the ambassadors bridge the gap between EU and national level and help shape our editorial content. Want to promote your work? Build Up disseminates your research, projects and events through a variety of channels. Become a member to exchange knowledge with your peers. You can disseminate tools and resources, share good practices, and consult open source publications. Join the discussion on social media and become part of the Build Up community, or subscribe to our newsletter to receive the latest news. However you participate, the Build Up portal is here to inspire, inform and connect. Build Up, the European portal for energy efficiency and renewable energy in buildings. Join the community for opportunities and updates.
Good morning and welcome to today's webinar. My name is Aranzazu Galan and I'm a member of the Build Up editorial team. It is a pleasure for Build Up to host today's webinar and workshop event entitled Advancing Energy Performance Certification, Integrating Data, Smart Readiness and Renovation Strategies, brought to you by TIMEPAC Project and Build Up. This online workshop is split into 5 main parts and it will address some of the key issues of the future transformation of current EPCs along the lines proposed in the revised EPBD. Before we begin, we invite and encourage the audience to send us questions or comments to the speakers throughout the session. To do so, please use the GoToWebinar question function. These questions or comments will be addressed during the Q&A session. The agenda for today's webinar will be composed of the following sessions. Leandro Madrazo, TIMEPAC Project Coordinator, will introduce the TIMEPAC project. Vincenzo Corrado, Professor at Politecnico di Torino, will speak about enhancing the EPC through operational data. Boris Sukic, Senior Expert at the Joseph Stefan Institute, will talk about evaluating smart readiness and energy flexibility in buildings. Álvaro Sicilia, Senior Researcher at La Salle Universidad Ramon Llull, will talk about improving data quality of EPC databases through BIM. And finally, Susanne Geisler, Senior Expert at the Institute for Sustainability, Energy and Resources Availability, SERA, will talk about effective and efficient renovation passports for the transformation of the building stock. We will have some time at the end for Q&A from the public, moderated by Build Up. And now, with further hesitation, we will move directly to the first speaker. Leandro, the floor is yours.
Okay, good morning, and thank you very much to Build Up for organizing this webinar. So, TIMEPAC is one of the projects that the European Commission has funded in the last years on the topic of energy performance certification. TIMEPAC is a cooperative support action. That means that the goal of the project is not to develop new technologies, but to coordinate research activities and policies, to foster networking and partner exchanges, and also to conduct training activities like this one today. Okay, sorry, the previous one. This diagram here comes from the original proposal we put together 5 years ago, back in 2019. The diagram captures our vision for the evolution of certification from one-time label focused on a building as a standalone object to a more comprehensive, ongoing assessment that considers the building as part of the overall environment over time. We believe that our vision of TIMEPAC aligns with the recent Energy Performance of Buildings Directive, approved in May, and also with the objective of making EPCs, energy performance certificates, an effective tool for building renovation. Building renovation that considers not just the building itself, but also the impact on sustainable development. For us, for TIMEPAC, the certification process is not just a one-time task. It's a continuous data management cycle that flows through 4 main stages: generating, storing, analyzing, and using data, certification data. This cycle is not static. It continues throughout all the entire lifetime of the building, and this continuity allows us to assess and improve a building's performance over time. However, each one of these stages brings its own challenges. In the generation phase, for example, we still have quality and reliability issues, which the recent EPBD is trying to address. In the storage phase, not all European regions and countries have comprehensive EPC databases. And even when these databases exist, turning this data into targeted recommendations is still difficult. Finally, analyzing this data and exploiting the knowledge to create services for improving the building stock is essential, but there are still questions about which actors and which services can be provided from the analysis of these EPC databases. Data integration is therefore a key issue in the latest EPBD. For example, the EPBD highlights the importance of connecting national databases to EPC databases and also to the European Building Stock Observatory. EPC databases can also be related to renovation passports to track the renovation stages over time. To implement all of this connectivity between all of these components presents both technical and also local implementation challenges, which will need to be addressed in the coming years. Moreover, after the latest revision of the EPBD, EPCs have become part of a broader ecosystem, as we can see here in this diagram, which includes the Smart Readiness Indicator and also the levels framework. The integration of EPC with these certification schemes is also a challenge for the future development of building certification. In the first year of TIMEPAC, we analyzed certification methods across 6 partner countries. Following this initial study, we started to envision potential scenarios to enhance current certification processes. Our focus was not on creating new tools, but on exploring diverse scenarios to inspire ideas and collect insights. In particular, we consider these 5 scenarios: the integration of BIM with EPCs, this is the first one. The second one, EPCs enhanced with operational data. The third one, building renovation passport integration with EPC databases. Smart readiness and sustainability integration with EPC, and quality control of EPC databases for large-scale renovation. These 5 transversal deployment scenarios were conducted simultaneously across the 6 countries, allowing us to consider building certification at the European level. After developing these scenarios, we validated our findings through workshops with stakeholders to ensure that our proposals were aligned with real-world needs. And finally, we concentrated on knowledge transfer through training activities, which is a key component of the TIMEPAC project. Through the TIMEPAC Academy, we share these insights with professionals, building skills and fostering a deeper understanding of innovative certification approaches. I will provide now a brief overview of the key insights from each of the 5 scenarios, and a more detailed explanation will follow later in the next sections of this webinar. The first one, integration of BIM with EPCs. In this scenario, we explore the integration of BIM with EPCs to enhance data certification. We created for this purpose 30 BIM models across the 6 countries and applied existing certification tools, identified the gaps, and developed guidelines. The second scenario, enhance EPCs with operational data. Here we focus on adding real-time operational data to EPCs to improve their accuracy. New indicators for energy efficiency, for indoor environmental quality, and for building performance impact were introduced. In the third scenario, building renovation with renovation passport with EPCs integration, we examine how to incorporate the renovation passport into certification databases, creating a dynamic record of building improvements over time. For smart readiness and sustainability integration with EPC, we participated in pilot tests for the SRI, aligning EPCs with SRI metrics. And we created the TIMEPAC Code of Conduct for smart readiness and sustainability ratings, which is available in our website. And finally, for the procedures and services to undertake large-scale renovation, we assess the quality of the EPC databases in the partner countries to identify inconsistencies. And in this scenario, we could develop archetypes for energy simulations, identifying renovation opportunities at the city level. All of this work carried out in the last 3 years of the project is available on our website in different formats. First of all, the reports, the comprehensive report of the 5 scenarios, also in a summarized version in the fact sheets, and also the guidelines or recommendations coming from our work. In the final year of the project, the TIMEPAC Academy played a key role in knowledge transfer. We conducted 6 online webinars, this is number 7 actually, as well as in-person training sessions in 6 countries, reaching over 900 participants. We believe that this strong demand underscores the need for ongoing education in building certification and renovation, even beyond the project's conclusion. The TIMEPAC project ended a few days ago in October, but we believe that our work will provide valuable guidance as stakeholders need to adapt to the new regulatory requirements to help them to ensure advancement in building certification and energy efficiency in the future. I would like now to give the floor to my colleague, Professor Vincenzo Corrado, professor in building physics at the Politecnico di Torino. He will extend on the enhancement of EPC through operational data. Vincenzo, please, the floor is yours.
Thank you very much, Leandro. Good morning, ladies and gentlemen. This is the title of my presentation, Enhancing the EPC through Operational Data. According to TIMEPAC vision, a new enhanced EPC has been envisioned, basically based on 6 key requirements, which are here listed. The first one is ensure better data quality and process reproducibility, include a broader set of parameters according to a so-called holistic approach, evaluate the impact of advanced technologies, such as adaptive building components, building automation control systems, provide a clear vision of the roadmap for building renovations towards the goal of zero emission, be continuously updated, and being flexible with respect to the purpose and the user. In this presentation, I will mainly address the last but one point, so the topic of the integrations of operational data, with a view also to the broadening of parameters to be included in the energy performance certificate. The topic of operational data integration was addressed in our project in a transversal deployment scenario in which 2 guidelines were issued. A first guideline referred to the collections of data from building documentation, from actual energy consumptions, in-field measurements, and also subjective informations go through questionnaires. And this methodology of collection was tested on some representative buildings. Then some data analysis were performed using a standardized procedure and including both a standard and a tailored energy performance assessment. The relevant issue of the calibrations of the model, the assessment of the indoor environmental quality, the assessment, especially economic assessment of the energy efficiency measures, and the assessment of the impact of building automation control systems. The final aim was, of course, to explore the possibility of having additional performance indicators in the enhanced EPC. The preliminary phase regarding data collection is basically classifies the data to be collected according to the source. Data can be taken I cannot see the presentation anymore. Okay, thank you. Data can be taken from building documentation, for example, existing certificates, energy audit reports, etc. Can be taken also by in-field measurements and by questionnaires. And according to the availability and the analysis to be performed, the data can be also classified in real data, reference data that apply the so-called inference rules to determine the most probable data in case the real data is missing, and sometimes conventional or better standardized data are used. In the table on the slide, you see the data classified according to different kinds of data, for example, general information, geographical data, climatic characteristics of the envelope, geometrical characteristics, technical building systems, occupancy, consumption, economic, and the type of data used according to the type of analysis. So, for example, for the standardized EP assessment, we would typically use a conventional occupancy, while for a tailored EP assessment, the data on the occupancy are referred to the real occupancy. Moving to the data analysis, I must say that most of the analysis that we performed and that were then described and specified in the guidelines are based on well-established methods specified either in the international standards or in international guidelines. For example, as regards model calibration, the main reference was the ASHRAE Guidelines 14, issued in 2023. For indoor environmental quality, for energy conservation measure assessment for BACs, European standards exist, and so nothing was invented. Most of the methods were the methods specified in the international standards. Focusing now on model calibration, I'm going to describe the calibration as it was performed in our project. The model calibration includes some preliminary phases, which include the identifications of the type and temporal discretizations of monitored data against which perform the model calibration. Then the collections of all data that are relevant for the creations of the building energy model and for the calibration period. Unavailable data, if they are not mandatory, can also be derived from standards or other sources. And all these data are used to create a base model from which it starts the definitions of calibration scenarios and the following calibration phases. In this slide, you see some examples. In the table on the left side, you see different possible temporal discretization for different kinds of data. For energy consumption, for example, it is possible to start from monthly, average monthly values, or weekly, or even hourly data, while for internal temperature, hourly values are typically used in the calibration process. The two figures on the right side of the slide show two examples. On the on the top right side, you see a representation of daily energy need for heating based on a weekly period, represented versus the average outdoor air temperature on the same period. The different dots, different colors represent simulated energy need and actual energy needs respectively. And the straight lines are the so-called energy signature, which approximate the different dots. So the calibration in this case consists of a change of the input data of some parameters as to fit the green line to the black dots, so to the black line. In the second example, on the bottom of the slide, you see representations of hourly temperatures, simulated temperature versus monitored temperature. In this case, the bisecting line represents the target. The green dots represent the simulated results before the calibration, and the blue ones represent the situations after the model has been calibrated. So moving to the calibration phases, 4 different phases can be identified. The first one represents the executions of the simulation, the extractions of simulated energy consumptions in the comparison with the monitored data. Then phase number 2 is the check of statistical indices compliance with the limit values. I will show you some examples of these kinds of statistical indices. Then number 3, selections of parameters to be modified. And number 4, variations of parameters that can be varied either one at a time or combined. The steps from 1 to 4 are repeated until the calibration target is finally achieved. Regarding the calibration phases 1 and 2, they include the processing of simulated data to make this data comparable with monitoring periods. So the period should be the same. And as regards the statistical indices calculated, 2 main indices are applied according to the ASHRAE guidelines. One is the mean biased error, MBE, and the other is the coefficient of variations of the root mean square error. Also performing an energy signature, which is the straight line approximating the dots of points, is useful to perform a calibration. And moving to the calibration phases 3 and 4, they typically aim at modifying the energy signature before the calibration to fit the data to the monitored data, basically by modifying the slope and shifting the energy signature and acting on different kinds of data. On the left side of this slide, you see 7 different families, categories of data on which it's possible to play with the calibration that include the construction thermal properties, thermal bridges, ventilation infiltration rates, specifications on heating, ventilation, air conditioning systems, internal gain and occupancy profiles, heating, cooling set points, and operation profiles of the air conditioning and heating systems. The last phase of the calibration is the evaluation phase, in which it is possible either to represent the tailored energy performance, which is based on real occupation data, and the standard energy performance, which is based on standard user and the climatic data. At the end, it is also possible to define a kind of a quality index using also different colors that represents the level of quality of the model after the calibrations. Moving very quickly to another example regarding the indoor environmental quality assessment, and more specifically the thermal comfort. This kind of analysis is also based on some preliminary phases, which includes, first of all, the identifications of the indoor environmental quality category according to the building use. The European standards consider 4 different quality categories according to user expectations, moving from high quality for occupants with special needs to low quality, which are referred to non-occupied spaces. The most widespread category is the medium one, normal level of comfort, which is used for most new buildings. Then the definitions of a period of evaluation of the thermal comfort is based on 4 different possibilities. It is possible to play considering the winter season with the heating systems in operation, intermediate periods in free floating, so without any heating or cooling system, summer season with the cooling systems in operation, and summer season in free floating, which means without any cooling systems. It is also necessary to identify representative space of the building for which performing the thermal comfort evaluation, because the thermal comfort is based on a single space and not on the entire building. I'm trying to, okay, next slide. Moving to the evaluation phase, and this example refers to a free floating period, it consists of calculating the running mean outdoor temperature, from which it is possible to determine the thermal comfort operative temperature ranges. It is typically based on the so-called adaptive comfort theory. Then the calculations of the indoor operating temperature can be performed in 2 different conditions, tailored and standards. Again, tailored refers to the real user and standard to a conventional standardized user. And finally, calculation of the percentage of hours within the comfort range, and the definitions of a thermal comfort index based on the deviations of the temperature from the comfort range above defined. It is possible at the end also to classify by footprint the thermal environment and indoor air quality ventilation. The distribution in different category is, of course, weighted by the floor area of the different spaces in category. And through this kind of representation, it is possible to represent through different colors the percentage of time in which, and also of the floor space, in which different comfort conditions occur. And of course, this graph can be also extended to different aspects of comfort, so not only thermal environment, but also indoor air quality, and maybe also visual comfort, acoustic comfort, and other different aspects. The last 2 slides I'm going to present refer to the last 2 analyses performed. The economic evaluation, which is based on international standards. It requires the definition and calculations of maintenance cost, the definitions of energy efficiency measure scenarios, determinations of initial costs of the building, investment costs, and calculations of annual costs. At the end, the 2 economic indicators that were explored, calculated in our project were the net present value and the payback period, and they allow to compare different possible packages of measures and to analyze the cost effectiveness and affordability of these different interventions. My last slide is focused on the assessment of bugs. In this case, the international standards defines 4 different classes, ranging from class D, which corresponds to a non-energy efficient bug, to class A, which corresponds to high energy efficiency bug, and the TBM, which stands for Technical Building Management Functions. And it was explored how to determine the bug efficiency both for the whole building and also split by different services. By services, I mean heating, cooling, domestic hot water, and so on. This is the last slide, and thank you very much for your attention. And it's my pleasure to give the floor to the next speaker, my the floor is yours. Thank you very much.
Thank you very much, Vincenzo. I'm really glad that I have the pleasure to participate at this Build Up webinar. I'm going to tell you more about evaluating smart readiness and energy efficiency in buildings. This is, first of all, let's start with what we are doing and do we really know what we are doing. Of course, at the beginning, when we were analyzing energy performance of buildings, there were a lack of data. Energy auditing was the first and the logical step. And in this context, it was more or less everything was clear because the goal was to identify the opportunities for reducing energy consumption and related costs. And of course, from the point of view of end user and from his perspective, there were a need for a robust instrument for reliable verification of energy savings and active support to building operators. And all that was well connected through energy performance certificate, which actually enabled better informed final users, better informed building users, and all that lead us to comprehensive renovations that has been implemented throughout the EU. However, when we speak about the new indicators, we have to first of all identify what is the role of that indicators, why do we need them. The role of any indicator is to make a complex system understandable or easily comprehensible, which means that indicators should not be something that is used by a scientific community, but also it should be something that is understandable for the final user, for the ordinary people, for the people who are actually thinking about energy renovation of their buildings. Of course, an effective indicator or set indicators helps in determining the current position against established objectives. Current position means current energy consumptions, objective, which means a future energy consumption. Indicators should be smart. I like this a lot because they have to be specific, measurable, achievable, relevant, and time-bounded. And I always try to stress here, when you think about indicators, whatever indicator, please try to make them achievable. Because if you define something overambitious, and if the final user is realizing that he or she is not able to achieve it, then the enthusiasm is falling down and the actions is stopped. Now we move to the smart readiness indicator and its purpose. Smart readiness is something that, as an electrical engineer, I like a lot because it brings us to evaluation of smart ready services, which are categorized in 9 technical domains, from heating, cooling, domestic hot water, ventilation, lighting, to monitoring and control. The performance of each service is assessed against the 7 desired impacts of smart buildings. These impacts are energy efficiency, maintenance and fault prediction, comfort, convenience, health, well-being, energy flexibility and storage, information to occupants. All these things are helping us to understand what is the level of smartness in the building. In practice, of course, SRI is a very comprehensive indicator, considering a wide range of factors and providing a holistic picture of buildings' smart readiness. The key part and the most important one is the data collection. Accurate data is needed for the wide range of variables, and we are getting that data from site visit, from other reports, energy performance certification, energy auditings, interview with the owner, and that all motivated us at the TIMEPAC consortium to create also the flow, the data, to define the flow of for the data collection process and to identify the limitations. Once again, we concentrated on available EU standards. So if you are, many of you could be familiar with this flow of activities, because they are connected with the flow activities that are proposed in European standard 16247, which is dealing with energy auditing. We adapted that to the story of conducting the SRI audit. You can see here that very important step is the site visit and the additional data collection, because you can get a lot of data before actually visiting the building. But the crucial part is when you visit the building, inspect the systems, do the interview with the owner, do the interview with the facility and energy manager. Afterwards, you do the analysis and calculation of SRI, identify the potential energy efficiency and flexibility measures, and at the end, do the final meeting and presentation of your main findings in a proper way, defining also the action plan, how to improve the smartness of the address building. Combining activities and guidelines for effective SRI auditing was also a very important element of the TIMEPAC project. We tried to connect several activities that are connected with the buildings, from energy auditing to energy performance and certification, and also to SRI auditing and calculating smart readiness indicator and also sustainability indicators. Based on the new energy efficiency directive, energy audit is becoming a dynamic category. Many institutions, many enterprises will have to do energy audits. Also, based on relevant standards, auditors must estimate the future use of energy use and the consumption, which means that we need models. Also, it is required to identify, prioritize, and record opportunities for improving energy performance. And all this brings us to the key message that I want to send today to you. Combining activities is the key of the future success. If we combine all these activities, not just having one expert doing the energy performance certification, then the second expert doing SRI, the third group of experts are doing energy auditing, that will not bring us to a desired state. That actually we need to combine these activities. So energy, when I'm doing energy audit, I use the SRI tool at the beginning to identify the current situation, and also to get the impression what things could be improved, and then through models and through the measurements also analyze the potential impact of those things. This is something that you can also see in this slide, how we connect the preparatory activities with the performing SRI auditing, and also what are the main outcomes. You will see here that something that you can also find in the TIMEPAC Code of Conduct for SRI auditing and for SRI auditing and sustainability, calculation of sustainability indicators. You will see here that we also highly support introduction of energy management system. We highly support development of building energy models, building and information modeling. All that help us to objectively calculate the SRI, and also all that help us to calculate the future scenarios when the measures are implemented, and to calculate new values. Of course, the key question is how to understand the SRI. And if you've been dealing with the SRI, you probably noticed that when you do the SRI calculation for the existing buildings, they achieve the very low values. Owners, users, customers are dissatisfied. For us, from the experience we gained during the TIMEPAC project, we have realized that it is very hard to sell a thing when you get a very, very low values of the SRI. This also motivated us to propose another indicator, which we call it Smart Performance Coefficient, which compares actual SRI value with the benchmark value. And in that kind of in this way, the buildings that were performing well are also awarded with the higher values of the Smart Performance Coefficient. And also, this is the way how the future comparison, at least how we see future comparison of different buildings, because when we are comparing the SRI performance of the elementary school, we don't want to compare it with the commercial building or building from a retail sector. We want to compare it with the elementary school from another region, from another city. But we are fully aware that in order to have this fully operational, the database of buildings that are evaluated, that for which our SRI is calculated, has to be populated, and when we will have a higher number of SRI values, we will be able to do this kind of comparison. Also, extraction of energy and flexibility measures. I will give you a few practical advice. Always calculate the load factor and create load duration diagram. Load factor will help you to get impression what is the ratio between average and maximum load. Actually, this will give you information what is the potential to implement flexibility measures. When you calculate the energy, when you calculate the load duration diagram, you will see what is the amount of your load is actually the peak one, what is variable, and you will also be able to identify devices that can be transferred or that can be controlled. Also, you always, when you do the SRI assessment, you always need to provide the comments, because they are necessary for the extraction of energy efficiency measures. If you just take the tools and fill it with your grades without providing a comments, that is not useful, not for the final user, not for future exploitation. For instance, for the electricity utilities that want to explore the flexibility in certain areas. The comments are also necessary for the properly understanding of the SRR rating, and also if the SRR rating is commented, then that can be a proper element, a proper tool for aligning the common interest between ESCOs and building owners. Also, in this context, when you do it in a proper way, you can see that on your left side of this slide, you can see on the example of different buildings from Croatia and Slovenia, that actually improving smartness means also improving energy efficiency of buildings. Improving smartness means that you also tackle the context of energy use if you provide comments, and this is also extremely important if you want to provide a reliable assessment of energy consumption in buildings. As the conclusion, I would like to say that calculation of the SRI is definitely can be the basis for the identification of performance improvement opportunities. Don't forget, combine the activities, combine the SRI assessment with energy auditing, energy performance calculation. Don't be too strong on SRI, because it's in its early stage. Actually, testing phase across the EU is going on, so we are learning by doing. And I think that if we continue honest cooperation between different member states, we can have a very useful tool. I also advise you visit our website, check our proposal of TIMEPAC Code of Conduct for Smart Readiness and Sustainability Rating, and don't forget you need to explain the SRI score to the final user. And implementation approach should be always teamwork, honest communication with the key stakeholders, and your focus always must be on effective measures and follow up the measures and indicators that should be calculated. The next presenter, I'm really happy that today with us is my dear colleague from Barcelona, Alvaro Sicilia from the Ramon Llull University. Alvaro, it is my pleasure to introduce you, and I hope that you will have a fruitful session with you. Thank you.
Thank you, Boris, for introducing me. Hello, everybody. Today, I'm going to present the work that we did in TIMEPAC project with regard improving data quality of EPC databases through BIM. Okay, let's see. I think the slide should be moving. Okay, so the first question that we asked ourselves at the beginning of the project was the one that you can see on the screen. Are our EPC database is ready for the EPBD recast. In that time, in 2021, the EPBD was a working document. It wasn't approved. Indeed, it was approved few months ago. And with regard to this question, we wanted to know if the different member states and regions that are managing EPC databases, if they were ready or not. So to answer this question, we conduct an EPC database audit. And for doing that, we needed a methodology. So we devised this methodology with these 5 steps. First, we analyze the EPC databases that we have in the different member states. In our case, was for 6 databases: Austria, Cyprus, Italy, Spain, and Croatia and Slovenia. Yeah, 6 different databases. And we define a list of 15 different metrics that allow us to assess the status of the database. And then we develop a survey that was filled by the different experts in each database, domain experts and also EP database experts. And then we carry out interviews to detail the different answers of the different people. And at the end, we reported everything. So I'm going to show you some results of this auditing process. For example, the first metric is the number of users. As we can see in the screen, most all of the databases that we assess have used the contents of the database for different purposes. For example, quality control or creation of statistics of policy making. Yeah? And also we have another metric which is called number of linked data sources, and it tells us if the database, if the EPC database is connected to other sources or not. And this is important, yeah, because for example in the new EPBD they are focusing on new instrument like the digital building logbook, and they want to connect everything: the cadastre, the EPC database, the passports, everything should be all connected. Yeah, and as we can see, there are few databases that nowadays are connected to other sources. Then another metric is the simplified database complexity index, and this metric tells us if the database is complex or not. When I say database, I mean the data model that is behind the schema. And most of all of databases are not complex. We have the case of the Croatia that is a bit complex, but so that means that if a database is complex, means that when they have to modify it according to the new EPBD requirements, they will need more resources. Yeah? And then also we have the metric store monitoring data and store renovation passport data that tell us if there are nowadays databases that are storing this data that is required by the EPBD. And we can see that in our case, in our sample, only one database, which is Austria, was or is storing this kind of data. Here you can see the list of the different metrics that we have used, and all of this report can be found in the deliverable comprehensive analysis of data storage in the participating countries. You can go to the TIMEPAC website and you will find all of this report and all of these conclusions and metrics. Okay, so now, once we know how the EPC databases are with regard to the new requirements of the EPBD, the second question that we ask ourselves is the following. Can using BIM for EPC generation improve the data quality? And this question is relevant, yeah, because I guess that all of you know that the EPC data that we have stored is not 100% reliable, but we want to improve, yeah, this status. So our hypothesis is the following, yeah. Nowadays, or there are some practitioners that generate the EPC manually. They go to the EPC generation tool, they put the different data about the model itself, the properties, but they can provoke some mistakes, some errors, because it's a manual input. Yeah, so you have to go to the building, measure everything, or some scans, floor scans, and this provoke errors. Yeah? So our hypothesis is the following: if you generate a BIM model, geometric 3D of the building, also with the properties, with the analytical model, and with the mechanical, electrical, and plumbing model, if you put everything there in a BIM model, Then with a semi-automated input, you can generate the BIM, the EPC, yeah, this is the certificate. And probably it will have a better quality if you do that in the manual way, yeah, the traditional way. So this is our hypothesis, and for doing that, we think, or we thought that we have to go through an open interoperability process, and that means to use standards, yeah, data model standards like IFC, that allows us to, from a BIM model on the left side, to fit the different tools or processes that we want to carry out. The EPC, for example, the energy performance certification, or the building renovation passport, or we want to fit the digital building logbook. So we need a way to centralize all of this data about the building. And one way to do that is using BIM and open interoperability. Open interoperability is an effort, so we need resources to do that, to play with BIM, to make BIM working with other tools. It's not cheap in terms of resources and time that we need to spend, and we ask ourselves if it is worth or not this effort. And okay, the big picture is the following. Yeah, you create the BIM today for a building. It will cost you time and money, of course, but this building can, or this BIM model can be reused over the time. Yeah, can be reused when you want to renovate this building in 10 years, in 15 years, in 20 years, according to the renovation passport that building should follow. Also, when the digital building logbook will be in place in few years, I hope, then also this BIM model can be used in that digital building logbook and can be used by the maintainer of the building, can be used for any financial instrument that you may require. So it's worth if you use this building for different purposes. You think, okay, BIM model only for the EPC, of course it doesn't make sense. But if you have the big picture, then it's the way to go. So when we face this issue about the open interoperability, at the end it's in the hands of the software developers. So they have to solve this open interoperability. And we know that there are some issues, so it's not working 100%. And for helping the practitioners to move in that direction, we developed these guidelines. There are guidelines to generate an EPC from BIM data. And all this stuff is reported in this deliverable, and the guidelines will be soon also published in the TIMEPAC website. These guidelines foresee two scenarios. You have to develop the BIM model from scratch, so you don't have anything, or you have floor plans, for example, and you need to create the BIM model from this data, yeah? Or you already have a BIM model, and you want to validate it. You want to ensure that this BIM model can be used for generate an EPC. So this is the process that we describe in the guidelines. You start modeling the BIM, the architectural model, the analytical and the MEP, and the mechanical, electrical, and plumbing model. Then we provide some tips and recommendations on how to export to IFC. Then when you have the file, we provide also the steps and the methodology to validate that IFC and to ensure that you have all the data needed for the EPC in that IFC file. And then we provide also recommendations to how to import this IFC model in different tools. The tools covered by the guidelines are the following. For the BIM authoring tools, we have Revit and SIPE. For the viewers, the IFC viewers, for doing the manual checking, we have Solibri, US BIM Viewer, and BIM Center Server Center. And finally, for the EPC generation, we have covered SipeTerm for here in Spain, also the Clima HC700 for Italy, and E2 software that is used in Austria and I think in other countries. So the idea is that you start modeling. If you have any issue in the validation, you come back and you remodel or modify anything, some parts of the model, and then you start the process again. Yeah. So this is an iterative process that can, so you may need to go through it several times. If the model is already created, then you just start checking that everything is in place, all the properties of the different materials, different layers. Then you go to the validation and you follow the same process. Yeah. Okay, so if we go deep into the guidelines, this has these 3 chapters plus the annexes. The first chapter is about BIM data for EPC assessment, and we describe all the requirements and minimum elements that should contain the BIM model. Then we have a second chapter about information exchange for EPC assessment. And here we describe how the import and export should be carried out through different tools. And then we have an in-depth study in which we describe not so common cases, like a curtain wall, how should develop this curtain wall in BIM model to generate an EPC. Also, windows that are in between 2 levels. So these particular cases are described in this chapter. And finally, in the annexes, we have described all the steps that you have to carry out in the different softwares. So it's a very comprehensive list and tables that you can find in the annexes. So, for example, the BIM for importing EPC has this structure, the 3 models, architectural, analytical, and MEP model. And for each of them, we have the minimum required elements that should be model, general recommendations, and definition and explanation. So these are the structure of the guidelines. We have applied these guidelines to model 30 buildings in 6 countries. Some of them were created from scratch, and some of them were validated because we already had the BIM model created by a company. So we validated and we redo some parts of them. We had residential buildings and tertiary buildings, of course, and the input data was very well. We have various sources from floor plans to EPCs and to BIM models. Yeah? And the time that we spend to generate a BIM model, if we don't have the BIM, was more or less 12 hours, depending on the complexity of or if the building is big or not. And for a BIM model that is already there, we spend 8 hours to validate it and to redo some parts. So if we come back to the first hypothesis, if it is if we use BIM to generate an EPC, the input data will be reliable or not. In order to answer that question, that hypothesis, we conduct a reliability assessment that you can see in the screen. So we compare the different surfaces of between the architectural drawings and the EPC, and between the architectural drawings and the BIM model that we developed following the guidelines. With regard to the building surface, the different floors and the whole building surface, there are not so much deviations because the percentage of deviation is less than 1%. So we can neglect it, this surface, so this error. But with regard to other elements like the walls and the windows elements, here we have a big deviation. With regard to EPC and the architectural drawings, which could be the traditional EPC generation, we have up to 14% of deviation with regard to the window surfaces. And with regard to the walls, it's above 2%, above 6%, depends on the different building. But if we do the same calculation using the BIM model that we have developed, we can see, which is the green bar, indeed we cannot see it, yeah, because the deviation is so small. So through this reliability assessment, we can say that if we use BIM, the EPCs will have a better input data and will be more reliable. So to conclude the takeaways, so it's the one that I said before, yeah. So using BIMs to generate EPC will improve the quality of the input data, as we can see in our examples. The interoperability between tools is the key challenge. It's not solved yet. The guidelines is a step forward, can help to reduce the burden of making interoperable the BIM authoring tools and the EP generation tools, but still it's not solved. And finally, as I said in the beginning, creating this getting this EPC from a BIM model is not worth. Yeah, only for generating an EPC is not worth. We need the big picture. Yeah, so we need to understand that this BIM model that is created today can become an asset for future renovations and for future uses of the building in the whole life cycle. Okay, so that's my part, and now I want to introduce Susanne Geisler from SERA. Susanne.
Thank you very much, Alvaro. I'll talk about effective and efficient renovation passports for the transformation of the building stock. So that is also a topic that is addressed in one of the guidelines we produced in the TIMEPAC project. So I'll start my presentation with two questions. Why do we need a renovation passport, and aren't EPC recommendations sufficient to improve buildings? In this regard, it is important to understand the difference between the EPC and the renovation passport. It is true that the EPC contains recommendations how to improve a building in terms of energy efficiency. But the main purpose of the EPC is to compare buildings, to compare them regardless of the user behavior, while the renovation passport is intended to initiate renovations. So the EPC is based on a standard user behavior, while the renovation passport takes the actual user profile and the energy consumption into account, and thus allows for, let's say, a more realistic assessment of renovation potential and developing renovation measures. So actually, the renovation passport responds to some of the challenges of the EPC, and in a way complements the EPC. For example, one of the challenges is that the EPC typically has a validity period of 10 years, which causes the problem that actually it's not clear if the publicized information relates to the actual status of the building. In this regard, it is most important that the renovation passport allows for tracking the implementation of renovation measures, because this would be essential for accurately presenting the current condition of the building. And as a second aspect, it would be most important to make this information available to policymakers who are directing the transformation of the building stock. Actually, the renovation passport is not new. Many EU member states have already implemented the elements, for example, as a consequence of transposing the amending directive 2018/844. So what is new according to EPBD recast? Since 2024, the process is specified. A digital tool is requested that links with the EPC database and ideally with the building logbook. And the roadmap that is part of the renovation passport, the renovation roadmap, should enable building owners to plan their renovation measures over time to transform the existing buildings into zero emission buildings well before 2050. So the EPBD recast contains a lot of specifications, and I'll just highlight a few of them. For example, that the renovation passports must be affordable. They can substitute the recommendations in the EPC. And maybe another important point is it needs to include the steps to transform the building into a zero emission building, so packages of renovation measures in the correct sequence. And three important elements, that is the digital tool, the link with the national EPC database, and to link the renovation passport with the digital building logbook when established. There is an Annex 8 that specifies in more detail how the description of packages of renovation measures has to look like. I will again just highlight that there is always the reference to the EPC. So we start actually with the current energy performance of the building, and after each implementation of a renovation step or renovation package, the energy performance that can be achieved by implementing that renovation measures needs also to be assessed. So we have that very close link with the EPC. So after having introduced the basics, I'd like to come to the second part of my presentation, namely how to set up a renovation passport scheme that is efficient and effective. And what do I mean by that? Efficient in that context means we need to save time and money and avoid repeated data collection. That means we make use of data repositories. You remember one of the requests was that the renovation passport must be affordable. The second aspect, what is effective in that context, it means that actually we aim for the implementation of renovation measures. So we need to track the implementation of renovation measures. We want to create an information base also for policy evaluation and adjustment of policy instruments. And in that context, it's also important to mention the link with the National Building Renovation Plan. So in practice, there are 4 core elements to achieve this efficient and effective renovation passport schemes, and that's the digital tool, the EPC data, the EPC database, and the digital building logbook. So the way how these core elements are organized and linked has an effect on the efficiency and effectiveness of the renovation passport scheme. In Austria, we have a digital tool that allows for EPC calculation and the renovation passport development, including the renovation roadmap. It is also possible to reuse data, and the tool links with the EPC database. That's the example of the province of Salzburg. How does it work? There is that interface with the EPC database where the EPC and the renovation roadmap is uploaded. And after the implementation of a package of renovation measures, the updated EPC and the updated renovation roadmap is uploaded again. And by comparison of the 2 versions, it's possible to track the evolution of the building in terms of energy performance improvements. So from what I presented so far, it's clear that we aim for implementing renovation measures, not just issuing a paper. And that means that the new scheme must cover the whole process, from analysis of existing data, complementing data through on-site visit, elaboration of the roadmap, proof of target achievement, securing financing for the renovation measures which are selected for execution, planning and execution of renovation works, update the EPC, update the renovation roadmap, and then the cycle starts again with the new measures which are selected for implementation. Regarding the use of existing data, regarding the use of data repositories, it's worth mentioning that the situation is quite different in the member states, and it would probably work differently to set up effective schemes, because in TIMEPAC, we actually identified that there are 2 approaches. We have EPC calculation tools, which include the energy model and the renovation road mapping tool. And then there are member states where we have dedicated tools for energy modeling, renovation road mapping, and EPC calculation. Another important point is to consider at which level of detail we are with our renovation passport. It's very important that the renovation passport is not a renovation plan. This slide shows packages of renovation measures for a building we worked with in TIMEPAC. And actually, we specify the right sequence to avoid lock-in effects and make this information available to the building owner or the facility manager to consider that or take it into account in actual renovation planning. With regard to data, it's essential, of course, the building logbook, so to reuse the data which are existing for a building. But with regard to achieving the 0 emission target, it is also essential to have information about the site available. For example, the solar radiation potential, but also district heating connection or district cooling connections. And in that regard, the municipal information system comes in, and it will be necessary in future to also find ways how to connect the building related, let's say, logbook and the municipal logbook. This brings me to the end of my presentation. To conclude, when member states develop their renovation passport schemes, they should do it in a way that it enables the benefits of such a scheme. And in that regard, the tracking of the implementation of renovation measures is an essential element. The most important aspects to summarize are the EPC data and the database, the digital tool, and the digital building logbook. In our project, we came to the conclusion that a BIM-based approach would provide a one-stop solution for that. With this concluding remark, I'm at the end of my presentation, and I hand over to the build-up team.
Thank you very much, Suzanne. Thank you very much to all the speakers for this very insightful and complete presentation of the targets and outcomes of the TIMEPAC project. Let's go to the Q&A session. We have some questions for you that it will be interesting to answer. A first one will come from the audience. It's for Boris. It says the SRI technical framework, is to say the service catalog or the weighting factors, etc., is likely to be improved at the EU level and adapted at the national levels before the 2027 milestone. What are your key recommendations in this regard?
Thank you very much. Thank you very much for this question. The key recommendation is try to be, with this adaptation, we should try to align to the specific needs of each member state or each region that is affected, or each region for which we are calculating those weighting factors. For instance, some things that are very important or big issues in Nordic countries cannot be, and they are not the same in the southern Mediterranean countries. Also, in some cases, the flexibility of buildings, for instance, if we compare buildings in Slovenia with the buildings in Portugal, not the same things have the same weighting factor, should not have the same weighting factor. For instance, in our case, we have for certain level of buildings, we usually have also the emergency generators for generating electricity in case of power shortages, and those flexibility services are usually also exploited in Slovenia. And that is very peculiar. That is something that is very peculiar, something that is specific for Slovenia, and I doubt that it can be translated in some other countries. That is the way why we are doing. That is the reason why we are doing why we are conducting the SRI testing phase in different countries, evaluating the potential impacts of originally proposed weighting factors, and trying to apply also and use method C, where we define the weighting factors based on our experience. Also, I must say that we in our case, when we are doing the SRI testing phase in Slovenia, we are also thinking about including another domain related with the facility management, because at the moment current methodology doesn't address it at all, and we think that the SRI should include this additional domain too.
Thank you very much, Boris. Alvaro, the audience is shooting you back a question. After 4 years project, are EPC databases ready for EPBD recast?
Well, some of them, yes, some of them, they are not ready yet, yeah? Well, we have to think that the EPBD has been approved, or has been, approved a few months ago, but it has to be implemented by the member states, and this will take time. I think it's 2 years. So each member state has 2 years to implement the EPBD, I think. So they are not ready yet, yeah, but I hope that it will be soon.
Thank you very much. Vincenzo, can a tailored energy assessment be used in place of the standard assessment for assigning an energy class to a building, or should it serve as a complementary analysis?
Yeah, thank you for the question. My opinion is that tailored assessment is really very important, but it cannot be used in place of standard assessment. Because the standard assessment is independent from the real specific user, so it's a better approach to compare different buildings, different building units, considering their specific characteristics. But at the same way, having this additional information as a TIMEPAC project proposes is a very powerful way to have also an idea of about the quality of the user. So how correctly is the building managed by the user? Because a very high gap between the standard assessment and tailored assessment can highlight that the building is not used properly, and it can lead to some measure mainly based on the operations of the building and its systems instead of renovation of the envelope or by transforming envelope or other kinds of systems.
Mm-hmm. Perfect. Boris, you have made a lot of emphasis in the smart readiness indicator. It's true that there is not users, let's say, they don't understand it yet very well. What technologies enable smart readiness and energy flexibility in buildings?
Yeah, there are different set of technologies that are supporting the smart readiness in buildings. A lot of sensors, a lot of smart meters, a lot of those devices are essential for enabling smart readiness of the buildings. For instance, today, if you are thinking about renovating your heating system and thinking to replace the old gas-fired boiler with a new heat pump, then I highly advise you to think about the heat pump, which will already be smart ready, which will enable you to exploit the flexibility of your heating system. In that way, your building will be much smarter. You will not spend much more money than if you are buying the heat pump without that functionality. And also, when you are thinking about the renovation of your heating and ventilation and air conditioning system, additional sensors will not make your system much more costly, but it will help you to exploit the full functionality of flexibility and smartness of that system. So smartness of a building is directly connected with the amount of additional devices that should be installed throughout the building. But those devices will also help you to optimize the energy performance of your building, which means that they could lead you to the lower costs of lower operational costs of your building.
Awesome, because you have also answered the question of the benefits. So
Yeah,
that is something else, but that's perfect. Let's go to Alvaro. Alvaro, what are the main obstacles to the adoption of BIM to generate EPCs, and how can they overcome? Although you have made a very good explanation during your presentation about this, but
Yeah, thank you for the question. The main obstacles, I would say there are two. Yeah, one from the technical side, because nowadays it's difficult to find software solutions that do this interoperability work in automated way. Yeah, of course, SIPE solution works, so you can model in SIPE and then you can generate the EPC in SIPE. But if you move away from SIPE world and you want to use Revit or other EPC generation tool, then there is information loss, and the user has to be aware of that, that there is information loss when you move data from one side to another. And the other main barrier is as a social. Yeah, the people don't want to spend time on learning BIM or spend time on generating the BIM model just to generate an EPC. Yeah, and we have conducted some workshops with different consultancy agencies and practitioners, and they don't see these benefits nowadays. Yeah, maybe in few months or years when the logbook is implemented and also the renovation passport is not optional and it's mandatory. I don't know. We will see. Maybe then these people they will see the benefits of using the BIM technology.
Yeah, absolutely. I mean, digital logbook, we are both Spanish, so we know how much is the libro del edificio. That is going to be digital now. It's going to change. But, you know, also the construction sector, which I'm part of, is complicated. It's quick and it's dated. So we need to really make a change there. Thank you so much, Alvaro. For Suzanne, I don't forget you. Building renovation passports, big topic. Is there one building renovations passport scheme or maybe several schemes depending on the building type?
Probably we will have several schemes, because when you remember, I said one request is the building renovation passport must be affordable. So we have different, let's say, requirements in the. If you think of a single family house and compare it with a multi-unit residential building, or then with a non-residential building, so depending on the size, depending on the use, we will have probably different schemes. Just to focus on the essential elements and to make it as efficient and effective as possible. And but in all regards, or in with regard to all the different, let's say, solutions, one element is everywhere the same, and that's the reuse of data to ensure the high quality of data. So there are two aspects: reusing data, avoiding repeated data collection, but also to ensure the quality of the data we are using. And these are challenges. In the project, we have tried to find ways how to deal with them. Alvaro explained a lot about it. I mean, in the renovation, we have additional, let's say, challenges compared with new constructions. Yeah, which would be a session on its own to deal with them. But that's, I think that's the key. So we will probably have different schemes. And everywhere will be the key question: how do we avoid repeated data collection and make use of data repositories and ensure the quality of data we are using?
Awesome, thank you very much. And continuing in the line of talking about data, Vincenzo, how can operational data contribute to improve the overall quality of the EPC?
According to large-scale statistical analysis performed on EPC databases, it was revealed that the quality of data is really a key factor. So it is necessary to improve the quality of data, because in some cases, it is really very poor. To this purpose, the operational data can be very useful if they are used for a calibration. So the calibration of the model is the only possibility to really improve the quality of data, and it's also a matter of perception from the final users. Because if the final user perceive the EPC as something which is just a formal document, so full of garbage, they don't really use it, and they do not exploit the information that is contained in the EPC. If it is perceived as a high quality document with useful information, of course, it can be a more relevant effect. And to this purpose, so the use of operational data is really very important and necessary.
Yeah, absolutely. In fact, in December, we are treating the topic of data in Build Up. So I think I'm going to contact some of you for a further further documents about that. So keep an eye on that. very interesting question for Suzanne, very down to earth. What do you think? How much money will the building owner be ready to spend for a renovation passport?
I'd say as little as possible. So,
For sure.
as little as possible. That's the reality. And this is why, again, I have to emphasize we have to really make the schemes very efficient, avoid repeated data collection. I can just repeat myself what I said before.
Yeah, absolutely. To talk with a final client, we need to absolutely simplify the language.
Yes.
Alvaro, very, very down to earth question. When are these guidelines available?
Yeah, we are we are doing the final checking. The guidelines are ready, so we have just to publish among other guidelines that we have developed in the project. I think that there are 5 at the end with the code of conduct that Boris has presented today, and they will be published, I think, probably next week, because we have to do all the final reporting. So all these guidelines will be available for all people.
Awesome. We will sure upload it in the Build Up portal. I will take care of that. And last but not least, Leandro, as our project coordinator, the TIMEPAC project unfortunately has finished in October. It has been a full trouble with you because in Build Up we have been traveling with TIMEPAC since the beginning. It's amazing the amount of keywords that you were touching: digitalization, smartness, digital logbook, skills, ongoing training. Absolutely amazing to be with you in your path. Which are your plans to continue with the activities in the TIMEPAC Academy?
Well, thank you for this company during the project. I think has been very intensive project, and I think we have carried out a very comprehensive view of all the issues that are now very challenging, considering the latest development of the EPBD. So I think our project was very much aligned with the directions that we see that are going to happen in the future, in the near future, for the transformation of the old concept of the EPC as a label to something more like a comprehensive assessment of building performance in the context of sustainable development, so in building renovation. So I think this is a completely different scenario that we were used to work with certification until now, and that opens a lot of challenges for professionals for getting further training, not only to understand the challenges of the EPBD, which is in itself an issue, but also how to transform and change our practices in the direction that the directive is showing. So that means that all the actors involved, from owners to consultants to architects, I think they have to be trained in this new direction in a way to get to know how they can change their practices and get new skills in order to move into this direction of the changing paradigm of certification, from certification to assessment. So that means that, and that's something that we could confirm in the TIMEPAC Academy during the project, that there is a real need for training. Who is going to provide that need? I mean, webinars like this one in Built Up or many other environments, they provide already professional training and in different aspects of certification. So the challenge for us is to keep this line that we have started in the project, and at the same time to collaborate with existing training environments and to provide these skills that are really needed in order to move forward. So I think this is our position at the moment. I think we contributed, to the debate about how to change certification to assessment. But now also, after opening this path, I think we have to see the ways to continue in professional development. It's a challenge, but it's a challenge for after the end of the project. Yes.
But we need to do it, and we need very specific, I think, skill workers in all areas. It's not anymore we all knows all. So what you have done is really an achievement. And it will be seen in future. Now it's just finished, but I think it's something that we will be seeing. So let's finish here. Thank you so much, Suzanne, Boris, Alvaro, Leandro, Vincenzo. It has been an absolute pleasure to accompany you in this webinar, in this 7th webinar. I hope that we continue to knowing about the results of the project and implementation. A big thank you also to all the audience for attending today's webinar. A reminder that you will be able to find the recording on today's session on the BuildUp portal and on our YouTube channel in the coming days. BuildUp has several webinar sessions already in the pipeline for the coming months, so keep an eye on the BuildUp calendar of events and our social media for updates on this. Be also sure to register on the BuildUp website to be able to share and disseminate your own content, and follow us on social media for updates. We wish you all a very pleasant and end of your week. Thank you and goodbye. Thank you again.